Hello there. Here's a publicly available AP Physics 1 question that deals with conservation of energy and collisions. As you can see in the diagram, we have two objects. One has mass m and the other one has 1.5 m for mass. Block right here is sliding down what is supposed to be a frictionless surface, and by the time it gets down before it slams into this one, it has this speed of 3.5 v0. And assuming that there is no loss of energy due to friction, we are asked to figure out this height. Conservation of mechanical energy, mgh should be equal to mv squared over 2. Mass cancels. H should be v squared divided by 2g. So 3.5 is 7 over 2. So it's going to be 49 v0 squared over 8 times g. The second question, question B, that gets us into collisions. We have a collision, and because we are talking about this moment when m and 1.5 m are right touching each other, we can disregard friction. I would say m times 3.5 v0, that was the speed before the collision, should be equal to m times v of m after the collision plus 2 times 1.5, that's going to be 3m v0. You can see this is 3m v0 and that's 3.5 m v0. So therefore m times vm should be equal to 0.5 m v0. So mass cancels and you end up with vm 0.5 v0. So it's also moving to the right. The next part is about motion on top of this surface, and they're telling us 1.5 mass stops after traveling distance d, and they want us to figure out mu. I'm going to show you two different ways. The long way, if we go for kinematics, we know that v final squared, which is 0 because it stops, should be equal to v initial squared plus 2 acceleration change in x. This is d, and this, because it's just sliding on surface that has friction, this is mu times g. So from there, d should be equal to, this is going to be a negative acceleration, v initial squared divided by 2 mu g, and v initial for the big one was just 2. So it's going to be 4 v0 squared divided by 2 mu g. Mu is going to be 2 v0 squared divided by dg. There you go. We answered the question about mu. Another way to do it would be through work. I could do force of friction times d should be 0 minus mv squared over 2. Change in kinetic energy. 1.5 m times 4 v0 squared over 2. This is a negative work done by force because force is going to be to the left and displacement will be to the right. So force of friction mu times 1.5 m times g times distance should be equal to 1.5 m. You can see that's going to cancel. 4 v0 squared. And all that is divided by 2. This cancels, becomes a 2. And we end up with mu being equal to 2 v0 squared over dg. Question D is asking us to figure out whether this collision was elastic or inelastic. The long way to do this would be to check kinetic energy final compared to kinetic energy initial. That's the final kinetic energy. What was the initial kinetic energy? 3.5 squared v0 squared over 2. So it's going to be 12.25 m v0 squared over 2. So comparing these two, we see that no, this collision was not elastic, it was inelastic. Is there an easier way? Yes, there is. In elastic collisions, the approach velocity, relative velocity, should be equal to the separation velocity. This one was approaching with 3.5 v0. After, this one is moving with 2 v0s, and the little one is catching up with 0.5. So this approach was 3.5. The separation is only 1.5 v0. So the separation velocity is less than the approach velocity, and that means that this is an inelastic collision. If you have any questions, please post them in the comments below. If this was helpful, like, subscribe, be kind.